Hello everybody, welcome into another lesson. So today we are going to talk about the law of sines. This will enable us to solve triangles. Now up until now we've been using right triangle trigonometry. We've been able to easily solve right triangles using Pythagorean theorem and basic trigonometry. Well, with the law of sines it doesn't have to be a right triangle, it could be anything. So the law of sines sets up three proportions, which you'll only use, of course, two at a time, but it's the sine of A over A equals the sine of B over B equals the sine of C over C. The law of sines only applies to three types of triangles. You have an angle-angle-side triangle, so if you're given two angles and a non-included side, or an angle-side-angle triangle where you have an angle, an included side, and another angle, you'll get exactly one triangle. And then there's another type of triangle, the side-side angle triangle, where if you have two sides and a non-included angle, this is what's called the ambiguous case. Because you could still have just one triangle, you could have even two triangles, or you could even have no triangle. The law of sines does not apply to a side-angle-side triangle where you have a side and included angle on a side, or a side-side-side triangle. These would fall under the law of cosines, which we'll get into in a couple of lessons. So let's go ahead and get started with some examples. So let's see here. We have that side B is equal to 60 degrees. I'm sorry, yeah, angle B is equal to 60 degrees. Side B equals 30. Side C equals 20. So let's set up our triangle here. This will be angle A, which would mean this is side A. This would be angle B, which would mean this is side B. This will be angle C, which would mean this is side C. A lot of people make mistakes with these when they set up their triangle wrong. So your side name should always be across from your angle name. That's how you'll get this accurately. Well, we know side B is 60 degrees. Let's set that up in here. We know angle B is 60 degrees. We know side B is 30. And then we know side C is 20. So what do we have here? We have two sides and a non-included angle. So in other words, this is a side-side angle triangle. This is the ambiguous case. We could have no triangle, one triangle, or two triangles. So let's set up our law of sines to figure out an angle. I'm going to vote we go with B because we know angle B, so let's take that sine of B, which is the sine of 60 degrees, all over side B, which is 30, set that equal to the sine of C, which we don't know angle C yet, all over the side C, which is 20. So that means 30 times the sine of C is going to equal 20 times the sine of 60 degrees, which then means that the sine of C equals 20 times the sine of 60 degrees divided by 30. And then C is just equal to the sine inverse of all that. Make sure your calculator is set to degree mode for this, because if you put it into radians, you'll be way off. You'll get something completely different. So 20 times the sine of 60, now divide that by 30, and then take the sine inverse of that answer. You would then end up getting 35.26 degrees, approximately. So we know angle C is going to work. The first test is in the side angle is, does your angle and the other angle that you know go over 180? Not even close. It stays well under 180. So we for sure have one triangle. But could we have two triangles? This is what we have to determine. How are you going to determine that? Take 180 degrees minus that 35.26, because you know you'll also get a positive sine value in the second quadrant, right? Which means you could have a second quadrant equivalent to this. So if I take 180 minus 35.26, I'll get 144.74. Which, if I add 144.74 and 60, that puts me well over 180. So for sure, there's only one triangle. Now, probably your easiest thing to do, since we know two of the angles now, is solve for that missing angle. So that means the measure of angle A would then equal that 180 degrees minus the 60 degrees minus the 35.26 degrees, which means A should have a measure of whatever that result is. We'll find that out. You would get 84.74 degrees. So now we know all three angles. Angle A would be 84.74 degrees. Now the only thing that's missing is side A. Well, let's take the law of sines. So we'll take that sine of angle A, which is 84.74 degrees, all over A itself, which we just don't know yet, equal to, we know side B and we know angle B, so that'd be the sine of 60 degrees all over 30, which means A times the sine of 60 degrees should equal 30 times the sine of 84.74. So A would equal 30 times the sine of 84.74 degrees divided by the sine of 60 degrees, which means we should be able to get a 2 decimal place approximation for side A once we figure that out. We should get about 34.50. So side A would have a length of about 34.50. That's what we should get. And there's plenty more where this came from, I assure you. Let me just erase this so we can reset the triangle and start over again. All right, what's the next one? So B equals 110 degrees. So we got side B to be 110 degrees. What else do we have here? We have angle C is equal to 30 degrees. So let's put 30 degrees here. And then let's see what we have for a side. Side A is equal to 15. Alright, so we have an angle side angle triangle. which means for sure we have one triangle. Well, the easiest thing's probably going to be to find angle A, right? So to find the measure of angle A, we'll just take 180 degrees minus that 110 degrees minus 30 degrees, which means A would have a measure of 40 degrees. So now we know all of our angles. Angle A is 40. Now we know side A, we don't know B, we don't know C. Well, let's set up our law of sines. So we could take the sine of angle A, in this case is the sine of 40 degrees, divided by side A, which is 15, set that equal to the sine of B, which is the sine of 110 degrees, all over our B. So that means B times the sine of 40 degrees would equal 15 times the sine of 110 degrees. So B is going to equal 15 times the sine of 110 degrees all over the sine of 40 degrees. And now we should be able to get a 2 decimal place approximation for the length of side B. Which would give you about 21.93. So side B would have a length of approximately 21.93. Now, we still need to find side C, so let's set up our law of sines ratios again. So angle A is the sine of 40 degrees all over side A, which was 15, equal to the sine of C, which was 30, so the sine of 30 degrees all over C. So that means C times the sine of 40 degrees equals 15 times the sine of 30 degrees. So C is going to equal 15 times the sine of 30 degrees all over the sine of 40 degrees. So now we should be able to get a 2 decimal place approximation for this. Which should be about 11.67. So side C should have a length of about 11.67. So there's every piece of missing information for this triangle, and I still have plenty more. All right. What do we got? We have B is equal to 130 degrees. So here's 130. What else do we know in this case? A has a length of 10. And then what else? B has a length of 8. Alright, so we have another triangle with 2 sides and a non-included angle. So this is a side-side angle triangle. So this is another ambiguous case. You could have no triangle, 1 triangle, or 2 triangles. Well, we know both side B and in angle B, so we're definitely going to use that in our ratio. So the sine of 130 degrees all over 8 would equal, now we know side A, but we don't know angle A, so we'll solve for angle A. So the sine of A all over 10, so that means 8 times the sine of A is going to equal 10 times the sine of 130 degrees. So that means the sine of A equals 10 times the sine of 130 degrees divided by 8. So A would equal the sine inverse of all that. So let's see what we get. And you end up getting about 73.25 degrees. You get 73.25 degrees. If you add that to the existing 130, you're well over 180. So this is actually a no triangle case. We don't have a triangle. That violates that the sum of the measures of a triangle equals 180. So there actually is no triangle in this case. Alright, what do we got next? So we have angle A is 20 degrees. Then we have side A has a length of 10. So let's fill that in for side A. That has a length of 10. What else do we know? Side C has a length of 11. Alright, so we have yet another triangle with two sides and a non-included angle. So this is another side-side angle triangle, which means we could have one triangle, no triangle, or two triangles. Well, we know angle A and side A, so let's use that in our proportion. So that means the sine of 20 degrees over 10 is equal to, now we know side C, but we don't know angle C, so let's solve for angle C. This would be the sine of C all over 11. So that means 10 times the sine of C equals 11 times the sine of 20 degrees. So that means the sine of C is equal to 11 times the sine of 20 degrees divided by 10. So C would be the sine inverse of all that. So let's go ahead and figure out C. You get about 22.10. So you get 22.10 for that angle. If you add that to 20, you only get 42.10. So there's definitely one triangle. Now, is it entirely possible that you have two triangles? So we know then that any first quadrant sine angle has an equivalent in the second quadrant because the sine's positive in both. So let's take 180 minus that 22.10. Let's see what we get. So 180 minus 22.1 would give you 157.9. Well, if you add 157.9 and 20, you're still under 180. You would have 177.9. So we actually have two triangles in this case. This is a case of two triangles. So we've determined our first triangle for angle C has a measure of 22.10. Our second triangle for angle C has a measure of 157.9. So let's go ahead here. This is where it's going to get fun. I'm going to erase some of this, so if you need anything from the video, go ahead and rewind and see how I work this out. But I'm going to write that C1 up here is equal to 22.10 degrees, and then C2 would equal 157.90 degrees. All right, let's erase what we've done so far here. So let's go on C1 real quick. Let's go on the C1. So if we want to find angle B1, so that means the measure of angle B sub 1 would then equal that 180 degrees minus 20 degrees minus the measure of angle C sub 1, which would be 22.10 degrees, which would then have to mean that B1 has a measure of whatever that result is, (137.90 degrees). So there's for your first triangle, you would have angle C with a measure of 22.10 degrees. Angle B would be 137.90 degrees, which means all we need to find now is side B. So let's set up our law of sines ratio. So take that sine of B, which is 137.90, divide that by side B itself. That then would equal, we could do either A or C, it doesn't matter. I'm going to vote we do angle A since it has an even number. That would equal the sine of 20 degrees over 10, which then means that B times the sine of 20 degrees equals 10 times the sine of 137.90 degrees. Actually, let's call this side B sub 1 because you're also going to have two side B's since you have two triangles. So that means B sub 1 would equal 10 times the sine of 137.90 degrees divided by the sine of 20. So B sub 1 would be approximately equal to, let's find this to two decimal places. That would be approximately equal to, did I divide that right? Hold on. What is 10 times the sine of 137.9? Yeah, I think I forgot to multiply something. That's why. My answer wasn't making sense. There we go. 19.60. So if we go based on the first triangle, you'll have angle A at 20, angle B at 137.90, and angle C at 22.10, with sides A being 10, C being 11, and side B being 19.6. Now let's deal with the second triangle. So the measure of angle B2 is going to equal, of course, 180 degrees minus that A of 20 minus that C of 157.90. So that means angle B2 would equal a very small angle, I'm going to say. I think it's going to be, what, 2.1, literally? Yeah, so you get that for the other triangle, angle B would be 2.10 degrees. A very, very small angle, 2.10 degrees. Now, we also need to find side B for the second triangle, so let's take the sine of that angle B, which would be the sine of 2.10 degrees, all over our B sub 2, set that equal to our sine of A, which is the sine of 20 degrees, all over our A of 10. So that means B sub 2 sine of 20 degrees equals 10 times the sine of 2.10 degrees. So B sub 2 would equal 10 times the sine of 2.10 degrees all over the sine of 20 degrees. So now we should get a 2 decimal place approximation for this second triangle. So let's see, 10 times the sine of 2.1, divide that by the sine of 20, you get about 1.07. So the second triangle would have angle A 20, angle B would be 2.10, angle C would be 157.90, and then your side B would be about 1.07. So you have two different triangles that this would actually work for. So this proves you have to check for two triangles if you have a side-side angle. Yes, I know, that one was rather awful. All right. Let's see. So we have C is equal to 95 degrees. So we have a C of 95. What do we got next? An A of 8. So A is going to equal 8. And then we have a C of 9. All right, so we have, again, another triangle with two sides and a non-included angle. So we have another ambiguous case triangle. We have a side-side angle triangle. So let's see. We know both angle C and side C. We only know side A, but we don't know angle A. So let's try to solve for angle A. So the sine of A all over 8 is going to equal that sine of 95 degrees all over 9, which means 9 times the sine of A is going to equal 8 times the sine of 95 degrees. So then you would get that the sine of A equals 8 times the sine of 95 degrees divided by 9. So then you just take the inverse sine of both sides and you'll get angle A. And then you would end up getting 62.31 degrees. Alright, well, 62.31 and 95 definitely don't go over 180, so for sure you have one triangle, but do we actually have two triangles? Well, again, every acute sign has an obtuse equivalent. So every first quadrant sign has a second quadrant equivalent. So let's take 180 degrees minus that 62.31 degrees, and what are you going to get? You get 117.69 degrees. Well, if you take 117.69 and add 95, you'll be well over 180, right? So this proves there's only one triangle in this case. So we know angle A now to be 62.31, angle C is 95, so we can easily figure out angle B. So that means the measure of angle B would be 180 degrees minus that 95 degrees minus 62.31 degrees, which now should give us an approximation for B. No, not 1800. Should be 22.69 degrees. Alright, so now we know every angle measure to be, that's 22.69 degrees. Now all we don't know is side B. We got to figure out side B, so we would then end up taking, let's see, the sine of that angle B, which is 22.69 degrees, all over B, set that equal to our sine of C, which is the sine of 95 degrees, all over 9. So that means B times the sine of 95 degrees would then equal 9 times the sine of 22.69 degrees. So then B would equal 9 times the sine of 22.69 degrees all over the sine of 95 degrees. So now we can get an approximation for side B. You would get about 3.48. So side B would have a length of about 3.48 degrees. And we got more. Alright, so let's see. A is equal to 70 degrees. So here's 70 for A. What else do we got? Angle B is 60 degrees. So good, we know two of the angles. That's going to help us. So B is 60 degrees. And then we are given a side of C being 25. So we have an angle-side angle triangle, which means there's definitely only one triangle. So this is going to be nice. because we know two of the angles, that means we can figure out the measure of angle C relatively quickly. That's going to be 180 degrees minus 70 degrees minus 60 degrees, which means C would have a measure of 50 degrees. So there's your angle C. Now all we don't know are sides A and B. So let's set up our law of sines. So definitely the sine of angle A, which is 70 degrees, over that side A, which we don't know. Now we know both angle C and side C, so this would be equal to the sine of 50 degrees all over that C value of 25. So that means A times the sine of 50 degrees equals 25 times the sine of 70 degrees, which means A would be equal to 25 times the sine of 70 degrees all over the sine of 50 degrees, which now we can get a 2 decimal place approximation for that side. You get about 30.67. So side A would be about 30.67. Now we just simply need to solve for side B. So again, side B, we know the angle at least, so that would be the sine of 60 degrees all over B. And I would use the sine of C for your second ratio since we know both the angle and the side. So that would be the sine of 50 degrees all over 25. Alright, so then B times the sine of 50 degrees is going to equal 25 times the sine of 60 degrees. So B would then equal 25 times the sine of 60 degrees all over your sine of 50 degrees, which now we can proceed to get a 2 decimal approximation for side B. That's about 28.26. So side B would have a length of about 28.26. And I got 4 more. Here's side C. All right, perfect. So we got C equals 16 degrees. So here's the 16 degrees. What else do we got? Side B has a length of 92. So let's set that up. And then we should have a value for side C, which is 32. If I could write. Alright, so we have another triangle with 2 sides and a non-included angle. So this is a side-side angle triangle, which means it's another ambiguous case triangle. So we know, let's see, we don't know angle B, but we know side B, so let's find angle B first. So that means the sine of B all over that side B, which is 92, is equal to the sine of C, which is the sine of 16 degrees, divided by that 32. So that means 32 times the sine of B equals 92 times the sine of 16 degrees. So that means the sine of B equals 92 times the sine of 16 degrees all over 32. So angle B is the inverse of all that. Let's see what we got. That would end up giving you, of course, 52.42. All right, well, we definitely can establish that there's one triangle because 52.42 and 16 are nowhere near 180. Is there a second triangle? That's what we have to establish. So let's take 180 degrees minus that 52.42. Let's see what we get. You get 127.58. And then 127.58 and 16 are also well under 180. So we actually have two triangles in this case. So another example of two possible triangles. So we'll say angle B sub 1 equals 52.42 degrees. And then angle B sub 2 is going to equal 127.58 degrees. So those are two possibilities of angles, or two possibilities for the two triangles. Now I'm going to go ahead and start erasing this stuff so we can figure out everything else. So let's go based on the first triangle with angle B sub 1. So let's find angle A sub 1. So the measure of angle A sub 1 is going to then equal, of course, 180 degrees minus that 16 degrees minus that B sub 1 of 52.42 degrees, which means angle A sub 1 would equal what? (180 minus 16 minus 52.42), you would get 111.58 degrees. So angle A for your first triangle will be 111.58 degrees. So now for your first triangle, you know angles A, B, and C. So let's find side A. Well, we know angle A sub 1 is going to be the sine of 111.58 degrees. All over, we'll call this side A sub 1, equal to the sine of C, which is the sine of 16 degrees, all over that 32. So that means A sub 1 sine of 16 degrees equals 32 times the sine of 111.58 degrees. So then A sub 1 would equal 32 times the sine of 111.58 degrees all over the sine of 16 degrees. And now we can get a 2 decimal place approximation for this. So let's go ahead and do that. That'd be about 107.96. 107.96. So your first triangle would have still angle C at 16, angle B at 52.42, angle A at 111.58, and side A with a length of 107.96. But we have a whole nother triangle. So let's find the measure of angle A2, A sub 2. Well, that's just going to equal, of course, still 180 degrees minus 16 degrees minus that B sub 2 of 127.58 degrees. So let's find angle A sub 2. You would get 36.42 degrees. So that means the second triangle, angle A, would be 36.42 degrees. Now we need to find side A sub 2. So we'll take the sine of A2, which is 36.42 degrees, over side A sub 2, equal to that sine of 16 degrees all over the 32. So that means A sub 2 times the sine of 16 degrees equals 32 times the sine of 36.42 degrees. So then side A sub 2 would equal 32 times the sine of 36.42 degrees all over the sine of 16 degrees. So finally we can get a 2 decimal place approximation for side A sub 2. You get about 68.93. So your second triangle would have angles 16, 127.58, 36.42, with side A having a length of 68.93. So either of these two triangles would work for this scenario. Alright, I should have 3 more. All right. Let's see. We have angle A equals 10 degrees. So here's 10 degrees. Angle C equals 130 degrees. And then what are they giving us for side? Side B equals 5. Alright, so we have an angle side angle triangle, which means we're only going to have one triangle. So it's automatically one triangle. Well, we know angles A and C, so angle B should be relatively easy to find. So measure of angle B would be 180 degrees minus 130 degrees minus that 10 degrees, which means angle B should equal 40 degrees. So that was relatively easy. Now what we don't know are sides A and C. So let's go ahead here, set up our law of sines ratios. So we'll find side A, so take that sine of angle A, which is 10 degrees, over side A, set that equal to, we know both angles B and side B, so the sine of 40 degrees over 5, which means A times the sine of 40 degrees equals 5 times the sine of 10 degrees. So A would equal 5 times the sine of 10 degrees all over the sine of 40 degrees. So now we can get a 2 decimal place approximation for side A. You get about 1.35. So angle A would be equal to about side A would be about 1.35. Now we can set up for side C. So let's see. We know angle C is 130, so this would be the sine of 130 degrees all over C is going to equal, well, we know angles B and side B, so let's use that. That would equal the sine of 40 degrees all over 5. So that means C times the sine of 40 degrees would equal 5 times the sine of 130 degrees. So C equals 5 times the sine of 130 degrees all over the sine of 40 degrees. And now we can get a 2 decimal place approximation for all this. That's about 5.96. So side C would be about 5.96. So there are all your values for this triangle. And I got 2 more. All right. Let's see what we're given. B is 35 degrees. So let's put that in, 35 degrees. A equals 12, side A is 12, so let's put that in here. And then what else do we have? Side B is 26. All right, let's see what we got. So we have 2 sides and a non-included angle. So this is an SSA triangle, meaning this is another ambiguous case. You could have 1 triangle, no triangle, or 2 triangles. Well, let's see here. We want to find an angle. We know both angles B and side B. Now we know side A, but we don't know angle A. So let's go for angle A. Let's set up our ratio. So that means the sine of A all over 12 equals that sine of B, which is the sine of 35 degrees, all over that 26. So that means 26 times the sine of A would equal 12 times the sine of 35 degrees. So the sine of A is going to equal 12 times the sine of 35 degrees all over 26. So then A would just be the sine inverse of all that. Let's see what the heck that is. Well, I get one angle of about 15.35 degrees. So that's one angle, and if you add these, if you add 15.35 and 35, well, you would end up getting only 50.35. So we can for sure establish that there's one triangle, but you know, every first quadrant equivalent for a sine has an equivalent in the second quadrant. So let's take 180 degrees minus that 15.35 degrees, and what do we get? $180 minus 15.35 would give you 164.65 degrees. Well, if you add 164.65 plus 35, you get 199.65. That's over 180. So this proves that there's only one triangle in this case. Alright, now since we know both angles A and B, we can find angle C relatively easily. So just go ahead and take 180 degrees minus that 35 minus that 15.35, and then that means C, we should be able to get an answer for that. That means angle C should be 129.65 degrees. So now we know all three angles, we just need to find side C. That's going to be relatively easy. Alright, so to find side C, we can take, of course, the sine of C, which is 129.65 degrees, all over that side C, which we don't know yet, and set that equal to our B, which is the sine of 35 degrees, all over our B, which is 26. So that means C times the sine of 35 degrees would equal 26 times the sine of 129.65 degrees. So C equals 26 times the sine of 129.65 degrees all over the sine of 35 degrees. So now we can get a 2 decimal place approximation for this. Of about 34.90. So side C would have a length of approximately 34.90. Alright, and there's one more problem, then we're done. Alright, we got angle C equals 145 degrees. So let's put that here, 145 degrees. What else are we given? Side B equals 5, which means side C has to equal something. Yep, side C would equal 9. Alright. So we have another triangle with two sides and a non-included angle. So this is the SSA case. So that's an ambiguous case. So we know sides and angle C, but we don't know angle B, but we know side B, so let's figure out angle B. So that means the sine of B all over that side B, which is 5, is equal to that sine of C, so that'd be the sine of 145 all over side C, which is 9. So that means 9 times the sine of B equals 5 times the sine of 145 degrees. So sine of B equals 5 times the sine of 145 degrees divided by 9. So angle B is the sine inverse of all that. Let's see what we get. You would end up getting 18.58 degrees. So 18.58 and 145 is still under 180. So for sure we have one triangle, but what about a second one? Well, if you take 180 minus 18.58, you're going to end up getting 161.42. You add that to 145, you're well over 180. So only one triangle is possible in this case. Alright, so we know angles C and B both. We can relatively quickly find angle A. So angle A would be equal to 180 degrees minus that 145 degrees minus that 18.58 degrees. So that means angle A will equal the result of that. Let's figure this out. That'd be 16.42 degrees. So angle A is approximately equal to 16.42 degrees. Alright, all we have left is side A. Now that we know both angles A, we know angle A, but we don't know side A, so let's put that in our sine ratio. The sine of 16.42 degrees all over A. Now we know both angle C and side C, so we can say that equals the sine of 145 degrees all over 9. So A times the sine of 145 degrees equals 9 times the sine of 16.42 degrees. So A is going to equal 9 times the sine of 16.42 degrees all over the sine of 145 degrees. So then that means A will give us here, we'll be able to get an approximation for side A. Of about 4.44. So side A would have a length of about 4.44. So now you've seen how the law of sines helps you solve for triangles without them having to be right triangles. Next lesson, we're going to find the area of triangles based on the law of sines, which means that those triangles also don't have to be right triangles. You don't have to draw altitudes. You can just know angles in the side, and you can find the area of a triangle using the law of sines. So I hope everyone has a great day. Take care.